We got some stored procedures to finish up. Last time, if you remember, we created invoice stored procedure, 3 different versions. So we saw how we could add more information to it to make it more reliable. And this one that they have an example for, the one we were looking at last time had an output parameter, if you remember. So up here at the top where we declared our parameters, we specified the keyword output. And when we called the stored procedure, we used that keyword output when we passed that parameter. So then that value was returned to whatever called our stored procedure. There's another way we can do it. We can actually use the return keyword. So this stored procedure is very similar to those ones we did last time, but it uses the return statement instead of specifying that a parameter is output. So let's try this one real quick. We're about done with our stored procedures. I've got SQL Server Management Studio open. I don't know why I always have to navigate to the database I'm using. I think it's many years as a Unix system administrator or Linux administrator where some days the database would just be gone. I think they're not doing check on. So I want to use, whoops, I'm not there. So last time we were talking about how some of our different components are saved differently. Is a stored procedure saved in our database when we create it? Nobody knows. You what? It is stored in the database. Very good. So just like a table, it's stored in a specific database. So it would have to be duplicated into another database if necessary, if it was doing some sort of system-wide checking. All right, in this stored procedure, we declared 2 variables, again, parameters. We have our date and our vendor var with our name, for our name matching pattern that we're going to use in our query. So for our code, after our as statement, we're going to start out with an if statement, checking to see if the date variable was supplied to us. And if it wasn't, we're going to go out and select a value from our table to supply that date. Bless you, bless you. And we're going to get that oldest date. So in effect, we'll be getting all of our invoices if they leave that date parameter blank. Bless you. We're going to use a variable, invoice count. And for our invoice count, we're going to load up that variable's value using a select statement with a count clause. We want to count the invoices that each vendor has. So we're going to join on vendor ID. And then we're going to limit with a where clause. And we want to use our date. So we want to check the date on the invoice row and make sure it's greater than or equal to the date in our date variable. And we want our vendor name to be like our vendor var. Missing an S there. Should be an @ sign at that point. Now, after we've gathered this information, we want to return the value of that invoice count. How many invoices were there that met our criteria?
So the takeaway here seems to be that if you don't mind doing this return statement instead, you don't have to declare one of your parameters specifically as an output.
Mm-hmm.
So you can do that either way.
Yep. So let's put a comment up there to that effect. Is stored procedure will return count of selected invoices using a return statement. And then just like our stored procedures last time, we want to use that EXEC, that execute statement, to execute our stored procedure. I'm going to zoom out just a little bit, get down here after our return, and I'll go ahead and put in our code to execute. So let's do execute the stored procedure. So I better put a go here. Now in the script, basically that executes our stored procedure, we're going to declare our own invoice count variable is an integer. And then just like when we call a function in a programming language that returns a value, we need to have a variable set up to receive that return value. So we're going to use our invoice count variable for that. We're going to execute our stored procedure. We're going to pass it a date. And we want all of the vendors that start with the letter P. Oops. And then after we execute our stored procedure, we're going to print an output message. Our invoice count plus our variable invoice counts value converted to a varchar, which is like basically a string, right? And I'll send this to you guys. Okay, so whenever you're ready, just try to run it. I think we've cleaned up all the errors and things. Here we go. So we got an invoice count of 6, which sounds good. Of course, we would have to validate that. I want to save this one then.
What did you do as the last thing before the execute?
Hang on and I'll put it back. So we'll do this one, EXEC, SP invoice count, return. See it? And then I'm gonna put this on the chat. Hang on. See where I'm saving those things. Okay, there's that code on the chat for you two out there battling traffic. All right, so we can do all sorts of programmatic things. Whenever you're, bless you. Again, this is one of those areas where you're going to be creating some stored procedures for your system, your application, where it meets the purposes of your application. Now, the next thing that we can do within a stored procedure is throw an error. Sorry, this printer's too good. It says that to you. Printer decided to just make all sorts of noise. All right, there you go. So we saw that we could use a try-catch statement in our code when we're creating code for SQL stuff, but we can also throw an error. So sometimes we want to generate an error condition. It's great for the system too. The system's going to throw errors like, this is a duplicate vendor ID, it's already on file, you can't save this vendor, that's a common one. Or things like, can't save this invoice because the vendor is not on file. That's a common error the system would throw. But what if we want to? We want to say, no, processing should not continue because there's some sort of error condition. In this script,
Why can't we do this in other languages?
you can do this in other languages. Return to your C# book and look at that new book because they do a pretty good job of showing you how to throw an error. So check and see. Well, they do kind of a confusing job, but anyways, it's possible. So we want to throw an error. Now, this procedure uses a lot of variables. So I'm going to send you something real quick. I think I've got them all set here, so we don't have to do all this extra typing. Probably take us just as long as it would for you guys to type them all. You're so fast. But we shall try. See if this works. Okay, so I'm going to send you this create proc statement. Maybe. Okay, is it a total mess? Can you copy it from the chat or is it all messy? I can save it and send it as a file if this is too messy. Is it too messy? Alex can't deal with it, it's messy. Hang on. I'll save it and send that. Yeah. Did I not press enter? Oh, let me press enter. Okay, try that. And I'll save it as a file. This one, I'm just going to save as exec insert invoice. Okay, I'm gonna send this as a file too. So does it look fine? Awesome, because that's what I really want is just that header stuff. All right, let's create a new query with that. And then we're gonna do a few changes because we're not ready to create this. Oh yeah, we are. Okay, we're gonna start out with this one. Do what? What? Huh?
I'm getting an error just from copying and pasting code, and it's saying that there's a incorrect syntax.
Oh, I just have something down here at the bottom. Do you have that little red down at the bottom? Is that it?
Yeah.
So yeah, don't worry about that because we'll be finishing it. So should be okay. We'll see. All right, I want to use my use statement up here above that. There we go. Okay, so we're going to start with a stored procedure. And a stored procedure stored in our database acts just like a function. We execute it with the exec statement. This stored procedure is going to validate an invoice, all of the data fields, before we allow it to be inserted into the table. So we're going to make sure that everything is correct. Do some data validation, some editing. Now our programmers, right, should have already done all this editing in the front end application, but we may need from a corporate standpoint to validate it here at this back end just to make sure nothing invalid gets through. So we have our procedure name, SP insert invoice, and then we have a vendor ID variable, invoice number, invoice date, invoice total, payment total, credit total, terms ID, invoice due date, and payment date. We have basically all of the columns for the invoice here. So that's why I wanted to send it to you, just because there's quite a bit there. Now I want to follow up with my code. So I need my as clause after all of those parameter names. Now the first thing in our stored procedure, we're going to check to see if the vendor containing the vendor ID they sent us exists. If we don't have a vendor, we've got a problem, right? We can't save this invoice. The database would throw this out, would reject this invoice, but if we control it, we can handle things much more smoothly and make sure that our errors or our users receive valid errors. So I want to select star from vendors where my vendor ID equals that vendor ID parameter. So if the vendor number is good, it does exist, I'm going to go ahead and insert that row into the invoices table. Now the values I'm going to use are going to be the values of the parameters. I'm going to leave some out. So stick with me here because we're going to be modifying this stored procedure as we go. So I'm going to supply the values for the vendor ID, the invoice number, the invoice date, the invoice total. We're going to put 0 and 0 in for our payment and credit totals. We'll add in some editing for those values soon. Okay, so our last row there, we've got terms ID, invoice due date, and a null value for our payment date. Now remember, even though that's quite a bit of code, that's really just one line of code after that if statement. Now in our else clause, we're going to throw an error. Say, didn't like it. We decided this error should be 50,001. And we do have specific error code ranges that we're allowed to use, and they vary by your different database vendor. So like for SQL Server, we can use a certain range. For Oracle, we could use a certain range because they use some of them. Now, we're going to supply not only an error number, but a message, not a valid vendor ID. Oh, exclamation point, big error. When this throw happens, our stored procedure is going to end execution, right? Because it's run into an error condition. Whenever a stored procedure ends, a return code is going to be returned. A valid return code is 0. We're going to be passing a return code of 1 that shows that an error condition did occur. Some program code likes to check those return codes to see if things were okay or not. So that's what that 1 is. Let's put some comments here for this thing. I'll do a block. That's what they have for this one later. And we'll put something like stored procedure SP insert invoice. And just put your name, and we'll put our textbook here. Textbook. And then in our script or stored procedure here, we're going to validate data and insert an invoice. Sometimes when we're working at school, our comments are more defining what we're looking at than what's actually happening. So that's okay too, if you want to put some in along those lines. So we do have lots and lots of parameters for this one. So let's call it. I'm going to put a go statement here at the end to end that batch, so it'll save that. And because we throw an error, if we want to catch that error, we have to use the try catch. So in our try, we're going to execute our stored procedure. SP insert invoice. Now we want to pass it some data, and we're passing as parameters. So with SQL Server, we just put them out there in the air. They're not in parentheses or anything. So our first parameter, which is going to be our vendor ID. Let me look up there, because since we're doing it in order, they're going to be positional. Vendor ID. Then our invoice number is going to be ZXK-799. Our date, 2016-0501. Amount, $299.95. Our terms ID is going to be 1. So I'm going to go ahead and back up here. Back up with me. And let's comment out our payment total and credit total parameters, because we're not going to use those in this call. And then we'll fix that as we expand on this stored procedure to make it more better. Okay, so after my invoice total, I'm going to pass the terms ID of 1, and then our due date of 06/01. So that means I might need to comment out one more parameter, our payment date. So I'll get rid of that comma up there. We'll revise it as we go. Okay, so when we execute our stored procedure, we could have named each of these parameters, and then we wouldn't have had to comment out these parameters. But since we're passing them in a positional manner, we have to make sure that things match up. I think there's still something, it's not telling me what's wrong here. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So hopefully that'll go away when we continue with our stored procedure. So after our insert, we want to end our try and begin our catch. In our catch, we're going to print out an error occurred. And we're going to take that error message that was generated by our stored procedure and convert that error message number into something that can be displayed. So notice that error message is a system variable. And error number. So we can check our error number. If error number, it's actually a procedure, greater than or equal 50,000, print out. This is a custom error message. So in SQL Server, any error number that's above 50,000 is one that was generated by the application. And that's going to end our catch. Notice that semicolon at the end of that entire structure, because that's definitely some interesting syntax. So I want to put a comment up here too that says execute our stored procedure. And we're going to be using an invalid vendor. So bless you. So we should generate our error. So let's try it. Ah, there it is. So nice error. Up here.
Yeah, so after the
Make sure you got rid of this comma there. That's my fault for commenting out that very last thing. Do you have your use statement?
Yeah.
See if is it running the right one? The right script? Is it doing something? Do you have something selected by it?
And then I also create one procedure.
Hang on. Keegan's going to show his because he's having a weird problem that I cannot. This chicken. Okay. Can you guys see what's wrong with this one? He's getting an error on line 1. Incorrect syntax near go. I think you should copy that and whole thing and close SQL Server Management Studio and reopen it. Just because. Maybe you've like lost your connection, it almost acts like.
Well, as a use state, yeah, my use state doesn't.
Type it again.
I guess my go is struggling too.
Do what?
I guess the go
Just hates it.
I guess.
See if the whole thing will work without it. Do you need to move the comments down? I think that's where my comments are.
Maybe you need to have the go after the comments.
You're fine. I thought you saw something. You're like, fix it. Like, yeah, you see something. I don't see anything. Weirdest thing. Create. Doc. You are? I think that's a semicolon.
You already run the use statement, right?
Yeah, but if I run it with the go,
It will move the go and the use statement.
do what?
Don't you see it? Don't you already run your use statement?
Yeah, just get rid of those.
Oh, okay.
So does that work for you, Taylor? It has to be something about those comments, getting it confused with the stored procedure, because
You're close to where well, one.
what about you, Noah? You still got errors?
Yeah, I just like highlighted everything.
Get it to fix. Is it okay now?
Yeah.
Got it. All right. Thank you, sir. Whenever you're working with stored procedures, you can have a little bit more peakiness like that. So you'll get to where you just have your specific way of doing it so that you don't run into those kinds of problems. And I would assume that we could put the comments maybe after the as statement and have it be more reliable. All right, so let's continue on with our stored procedure here. So do what? Where do you want to go? Right there. Is that good? Okay. So right now, our stored procedure checks and makes sure we have a valid vendor ID. That works good. It throws that message if we don't. So we could get a little bit more involved here. Let's add a few more lines of code. Are we ready? Ready, ready, ready? Okay, let's save this one. I'm gonna name it EXEC insert invoice 1. Now we're gonna add a little bit more this time. We do want our payment total and our credit total parameters. We also want payment date. So I'm gonna uncomment it and put a comma there. We're gonna leave the beginning of our script where we're checking our vendor ID. That all looks good. We're just gonna switch it up just a little bit. We don't wanna do the insert at this point because we're gonna check a few more things. So let's change our if statement to be a not. And we'll throw that error if our if statement is true. Now I'm going to move that insert statement down because we're going to put a few more if statements in before we're actually ready to do our insert. So the next thing that we want to check is our invoice number. An invoice number could be any sort of format because that comes from our vendor, but we can make sure that there is something there. So we're going to say if that invoice number is null, we've got a problem. We're going to use that same 50,001 error. And at our company, we might have a whole manual of error messages. We might use different codes for different things, but they've decided that anytime they generate an error, it'll be this 50,001. Now, my message is going to say invalid invoice number. And again, we're going to set the return code at the system level to 1. We're also going to validate our invoice date. So if our invoice date is null or greater than today, or we're going to do a built-in function here. We're going to say get the number of days between our invoice date and today. And if it's greater than 30, then that's too old of a date. So all of those conditions would result in an invalid invoice date. Now in that if statement, we're checking for several different conditions and we're not really supplying detailed information back as to which one was our problem. But we've decided in our design that that's okay, as long as we say it's an invoice date problem. Okay, another one. We have all sorts of validation samples here in this stored procedure. We're going to use it later too. Now, if our invoice total is null, or if it's negative, those would both be bad conditions. I think I'm going to copy this line with the throw syntax. And I want to say invalid invoice total. We also are going to validate our payment total. For this one, we just want to make sure that we have something. So if we have a null payment total, we're just going to set it to 0. So we're not going to throw an error in that situation. We're just going to fix it. We'll do the same thing with our credit total. If it's null, we'll set it to 0. We could just do all sorts of checking. So lots and lots of validation. We can make sure that we've got this data all fenced off. Nobody can do anything wrong with it. Now we're going to check to make sure that our credit total is not greater than our invoice. If it is, we've got an error condition. We'll throw our 50,001 invalid credit total. And then let's copy those. And we want to check to make sure our payment total, if payment total is greater than our invoice total minus our credit total. Lots of rules. Then we have an invalid payment total. I see an error, a typo there. Now, we can continue on. Let's check our terms code. So we're going to use a not exists again. And we're just going to select star from terms where terms ID equal the terms ID that was sent into our stored procedure. If that not exists comes back true, we're going to see if that terms ID is null. If it is, we're going to select the default terms ID for this vendor. So we can do that by selecting the terms ID, and we want the default terms ID column for this vendor. Phew. Now we're going to put an else clause here. If that vendor, if that terms ID is not null and it doesn't exist in the database, then we've got an error. Invalid terms ID. Okay, so as you're typing all this out, be thinking about all of the examples that this is giving you here. So we have an example at the very beginning of making sure that something in our database exists based on a key field, a foreign key. We have some examples here of checking numeric values, checking date values. Now we have an example where we are going out to the database to set a default value based on a condition. So a lot of really good code here for us. A couple more, and then we'll be ready to finally insert this invoice. Lots to do to make sure it's valid. Now the next thing that we want to do is check that invoice due date. If it's empty, it's null, we again are going to set it to a value. So what are we going to do here? This is kind of an interesting one. Let's put in our select statement and we can look at it. Part of this is kind of a reason that in some of the majors you guys are required to take an accounting class so that you'll have a background with some of these kinds of concepts that are standard business accounting procedures. But what terms are an agreement that you have either with somebody you sell things to or somebody you buy things from. And in your terms, you might say, you get a 10% discount if you pay within 15 days, or you get a 10% penalty if you pay after 30 days. Depending on how you've worked with this person, this customer, you might give them a discount if they pay quickly. You might give them some sort of penalty. And that's what we're doing here is we're saying for this particular term, we set the term based on what was our default for this vendor. So what do we have, like 30 was a terms code that we have in our database. Now that we've set that term code, we're going to go out and find out what the due date value is for that terms code. Is it 30 days or 15 days or 45 days? What is our due date? Based on that information, then we can set this invoice date. Now, if the invoice date is not null, we got to check some more. The due date, I mean. If the due date is less than our invoice date, or we're going to do that date diff function again. So our limit is going to be 180 days. If we're trying to set this invoice date to a due date that's greater than 180 days, that like 6 months, that's pretty far, then we're going to say that's an error. Invalid invoice due date. One last one. If our payment date is less than our invoice date, can't be, right? Can't have made a payment before the invoice, the bill comes out. Or the number of days between our payment date and today is greater than 14. That's a problem. Finally, we're ready to insert our invoice. We validated everything, pretty much validated every single column on that invoice table as having valid data. So in our values clause, we do not want to send zeros now for these other numbers. So let's change that. After the invoice total, we have payment total. After payment total, we have credit total. And then our very last column, instead of null, we're going to pass that payment date because we worked on that and we made sure it's valid. Now I have a leftover else clause down there from rearranging, but I do want to return a value. The value I'm going to return to my calling function or script is @ identity. What is @ identity? Let's go Google it.
The last identity.
Perfect. So that should be what? Our invoice ID that gets generated. Good, good, good. So now we're going to know what the ID was that was assigned to that new table row because we're going to have it returned by the system variable. Now let's create a script to call that stored procedure. We already have most of it here, but we need to add a little bit more. So under your begin try, let's declare a variable. And we want to declare a variable to hold that invoice ID that gets returned to us, that identity column. Now we're going to fix up our execute statement a little bit. The return value is going to be our invoice ID variable. And instead of just passing these positional values, which was kind of messy last time, we're going to change it to be named values. Named parameters. Get rid of that IntelliSense so you can see what's going on. After vendor ID, we're going to have invoice number. Then invoice date. Invoice total. Now I'm going to get rid of these other items because we're going to let our stored procedure figure those out. We want to change a few other things. Vendor ID, we're going to leave it $7.99, but let's change our invoice number. They want it to be RZ99381. We want our date to be 04/12 of 2016. And we want our amount to be $1292.45. Is that far enough? Okay, after our insert then, we should be able to print out some information. The row was inserted. Let's print out that invoice ID. In our catch, they'd like us to add a little bit to our error output too. Instead of just saying an error occurred, we're going to say an error occurred, row was not inserted. our next line will print out error number. And our error number. And then I'm going to get rid of this one. Nope, the if statement is what I'm going to get rid of, sorry. And then they wanted to say error message. Phew. I feel like you wrote a whole program. You did. I mean, it's pretty intense. You've gone out and created a validation routine for every single column in this really large table. Actually, I mean, it has quite a few columns for our tables. It's pretty important. It's a lot of things. So we run it. Let's run it. Oops. My SP insert invoice script or stored procedure did work, but I didn't update it. I ran the old one. Did we all run the old one? Let's go put a drop and a recreate up here. And then I should see something better because it's weird because I got some of my new messages. So it sort of acted like it updated it. Pretty strange. Okay, so not a valid vendor ID. So let's make it a valid vendor. Yes, sir?
I'm getting a couple of errors saying that create alter procedure must be first statement.
Uh-oh. Get rid of your use and go again. And it's still doing it. Will it let you do it?
Oh, wait.
Because mine is red too. Sometimes you might have to open a new query window and just do your drop if it's being weird. Uh-huh.
I got permission denied in database master, even though I'm using mine.
So it must have switched. It's not using the right one. Make sure you have it open over here in your object browser.
I still have a few of where the invoice date.
Uh-huh.
I had a couple of the, I believe I have about, there's a couple of the if statements.
Oh, okay. Here, let me bring those up. That's fine. We did a lot of them. They're crazy. So this one is super intense. It's a really, really good example. Like I said, though, if you can keep it, you should be able to use it for a lot of different validation that you might run into. So it's a very, very good example. Try some different values with your running your stored procedure. Try valid vendor IDs with invalid numbers and invalid dates and see if you can test some of your different areas. in a real world situation, your test plan would include invalid data for every single one of these columns and every single one of these conditions, so that you would be sure that they were all properly tested every time the test plan were executed. So be aware of that, you know, that we not only do we put this code in, we have to make sure that every single possibility here gets tested. Now, if yours is working, save it. I'm going to save mine and can test with it as much as you want. Let me know if we need to go back to it to get something working, but I'm not going to post it because it's in our book and in the PowerPoint. We want those people to do it on their own who didn't do it. Okay, so the next thing that they present to us, like I said, this is a really long one. Our last chapter was like super short. This is a user-defined table type, so we can actually create a table here as we go. And in their example, after they create this user-defined table type, we're saying this is a line items type, then we can read in our table row is a parameter because we've created that table type. So it's kind of like just saying all of these parameters exist on this table type. If I read in this table type, that's what I'm working with. So they have just a real quick example or two of that in the book that you can try. And then of course we can drop procedures and alter procedures like we can other types of entities. They're altering it and then dropping it. Okay, store procedures that are available from the system. Whoa, these are really good. So come with me if you were getting lost there, sidetracked, come back, because these are all pretty important. Let's try one of them or a few. Bring up your SQL Server Management Studio and open a new query, and you can put in your use statement. And then I want to do SP_help. In the syntax that they give us in the presentation, it says that after the keyword help, we can use an optional parameter of name. Well, here are all the names that we could use. So all of these different names exist in our database somewhere, so we could do some help on them. Notice we see all our tables, we see all sorts of different column names. So let's see, I think I'll do SP help on top vendors. What is that? Bless you. Now run it. And it says everything for it, doesn't it? It tells me about it, that when it was created, what type of entity it is. Oh, it's a view, who its owner is, and then columns that are part of the view, and some other things. So depending on what kind of entity I'm asking for help on, we get all sorts of different values. So let's do SP who and execute that. All of these background things are tasks that are running on our server that are just waiting for somebody to ask them to do something. And then as I get moving, I start seeing people that are logged in to our server and what database they're connected to. So we have some people that are connected to the master and some people that are connected to their own database. This is a really important display because as a DBA, when you're trying to do maintenance to a table or a database, you won't be able to do that if somebody is currently using that table or database. And that person might be somebody that works at your company that left 7 hours ago, but left themselves logged on. And they still have this active connection to the database, so it won't let you do whatever you need to do to fix that table. So you might have to run the SP-who command to find out who is active and what their process ID is, so that you can kill their process on the server and get them disconnected. So not a gentle process either. It's going to kill their session. But sometimes that's what we have to do. Now, the other SP commands that they showed us are things that, again, will give us additional information about our database or the login or any sort of column information that we want. So there are lots of SP_ stored procedures that are available and that are super, super useful. So I'm going to try those. They've got a few more examples. Well, we've looked at stored procedures, we've looked at scripts, and now they're saying, you know, you can create some user-defined functions also. A scalar valued function, if you remember, a scalar value is a single value. So try to get that really stuck in your head. Scalar means just one value, like a final total. We can also have a function that returns a table that's based on a select statement. So we could have a pre-built user-defined function that creates a table for us, or we could have a function that returns a table that's based on multiple statements, so that took a while to create. All of those things are possible when we're looking at user-defined functions. Now, when you look through this section, this is a section that I'm going to leave for you on your own. Do try the different examples and make sure that you feel comfortable with them. They're very similar to the things that we've already done, so you should feel pretty comfortable. But I want to kind of skip on to triggers. I'm going to move here to page 49 of this awesome presentation about triggers. First of all, let's look at this trigger syntax, and we can come back to it next week if we need to. But I wanted to get started because I know some of your assignment has some information about triggers in it. When I look at the create triggers syntax, I see some things that are different from creating stored procedures or creating functions or these other things that we've been creating. Leaving out this middle row, the with encryption and the execute as clause, focus on that syntax that's different. With a trigger, we're saying I can associate this trigger, which is some code, some SQL code, with a table. Why is this called a trigger? Well, it actually is important that that's what it's named. What is a trigger? Like something that fires a gun?
Something that executes when condition.
Yep. Well, what's a trigger outside of programming is the thing, because that's where the term came from. It's part of a gun, right? It fires the gun. And firing is an important concept for a trigger. And that's actually why it has that name, because it's based on that concept. Because if I want to shoot a gun, I pull the trigger. If I want to execute this code, I make the action happen that fires this trigger, that makes it execute. What action is that going to be? Well, it's going to be either the insert of a row in a table, the update of a row in a table, or the delete of a row in a table. So my trigger is going to get control of execution based on when I say this should happen. Before the update, after the update, or instead of the update. So my code can do some things like validate that invoice. We set ours up as a stored procedure, but it's probably better code to put in a trigger, right? Because then we could say, if somebody's trying to insert an invoice, execute my code that's going to validate all of those columns. It's going to return an error if there's a problem. That's why we wanted to return those errors, so our trigger would work. So when we're working with a trigger, besides defining when it should fire, which is super important, really think about it. for your MTA exam, triggers are one of the things that are questioned a little bit because it's kind of a concept that can be left behind by some people because they're like, oh, that sounds hard. It's not hard at all. Well, all it is saying, on my invoice table, when somebody tries to insert, I want you to run my trigger instead so that I can do that insert myself. Now, when that happens, I'm going to need to know what kind of data they were trying to insert into that table. And I'm going to be able to find that in this special table called inserted. This inserted table is going to exist only while my trigger is executing. And it's going to be the system's version of what would be inserted or what was just inserted. Same with the deleted table. How can my trigger do something if something was just deleted? Well, I can see what was deleted by looking at this special deleted table, and I could put it back if I wanted to because I can see the data in the deleted table. So I can have control. So our trigger, same code we've been using for everything else. What's important is deciding when this thing executes. So let's take a look here. Let's do this one, and then we'll stop for lab time here, and we'll do some more trigger stuff next week. But at least you'll have seen a little bit if you don't want to wait on the assignment, but you're welcome to wait. So I'm going to create a new query window. Use my database, and I don't know why it won't let you guys use yours. And I'm going to use the syntax create trigger. So my create always needs that type of object that I'm going to create. And this trigger is going to be called vendors because our textbook has a common convention that for triggers, they name the trigger first the name of the table, then an underscore, and then when the trigger will fire. So they're putting insert and update in the actual name of the trigger. Then we have to have the on keyword that says this is going to work on the vendors table after an insert or an update. Now we finally have our as keyword to put in our actual code. So our code for this one is we're going to be updating the vendors table. And what we want to do is set our vendor state equal to the uppercase version of the vendor state. So this way, if somebody's typing it in and they do MO like with a lowercase o, we'll fix that. So instead of giving them an error message and kicking it out and making them fix it, we'll just fix it. We want them to all be in uppercase. So where? Now I can't just set that vendor state because I would do that magic thing of updating every single vendor in my trigger. Because my trigger is not going to be selective about just using the one that it was just updated. It's going to get every vendor row unless we use a where clause. So in our where clause, we're going to say, I want the vendor ID that was in this inserted table. So now we're saying, look at the inserted table, get the vendor ID, use that vendor ID to update the vendor's state. Notice that this is a whole collection. We could be getting back multiple vendors. So if our update had actually updated multiple vendors or we'd inserted multiple vendors, our trigger would have that information. But it's kind of a moot point because the trigger is going to execute for every single one of them. So it's not going to ever see a collection. So let's put our go statement. That's the end of our trigger code. And now let's insert into vendors. And we want to do Peerless Uniforms Inc. 785 South Hickley Road. And you can, of course, make these shorter than a null value. EIQUA. We're going to make our state be Ohio with the lowercase h. Four, 5, 3, 9, 3, 7, 5, 5, 5, 8, 8, 4, 5. Ugh. Lots of columns in our vendors table.
There's supposed to be a space after the phone proceeds and the phone number.
They have it. But we would need to write a trigger to validate that, huh? Okay, for our trigger, we are going to execute it here with this. Let's go ahead and select from our vendors table to validate that. Where I'm just going to get where vendor name equal this Peerless Uniforms Inc. We could probably use any of our data fields there. And we'll make sure that our OH with the lowercase h got converted to an uppercase. We could do one more set. I'm going to put something else in there. It's hard to debug a trigger. So you know how if you're trying to debug some code and you don't have a good debugger tool or anything, you'll use some print statements or output statements, or depending on what kind of environment you're in, you might have to get creative. So for this, let's say we're going to set our vendor address equal to trigger ran. Mad at me. Vendor address one.
Yeah, comma after the trigger line.
That's my problem. Into my update syntax. There we go. So I just want to update that address one to say the trigger ran. And of course, I would only do this with test data, but sometimes that can be a really nice way for me to be sure that something happened. So I would have to put that back before I set it for use forever, but I'm going to go ahead and execute it that way for now. So my vendor address one says the trigger ran, so I feel good about that. I know it ran. And of course, my vendor state is set to uppercase like it should be, so that's good. Okay, I want to save that. And it's going to be my trigger update vendor. Well, actually, I should make it like they did, didn't I? Vendor insert update. Sorry. All right, lots that we can do with triggers. They are really, really powerful and allow the DBA to do some great work. Notice how much more complicated debugging can become now. Where did that error message come from? Did it come from the front-end application, the website? Did it come from some sort of back-end validation application from the database? If it's from the database, was it from a stored procedure? Was it from a trigger? So your debugging skills have to get deeper and deeper and deeper to try to find things. So definitely makes it more interesting, keeps your job. All right, I'm gonna stop there for lab time.